I'm redoing my binomial probability video because I had a mistake at the very end, and I don't like having mistakes in my videos, so I just wanted to redo it. That's fine. So here's the deal with binomial probability. It's working with discrete data, which means it's whole numbers. So the probability of snow for the next 5 days is 0.2, which means it's either going to snow on that day or it's not going to snow on that day. So if I want to find the probability that's going to snow exactly 3 days out of the 5, I can use my probability formula, which is this right here. It's pretty nifty, actually. It's very, very clever. It means NCR, N is the number of trials, R is the number of success, P is the probability of success, and Q is the probability of failure. So it's actually, like I said, it's actually quite clever when you think about what you're actually doing. And I always had a hard time when I was a student because I never actually paid attention to what was going on. Oh, my daughter is sewing, so that's very, very exciting for her. Good job, Phoebe. All right, so out of the 5 days, I'm going to choose 3 of them for snow. The probability that it is going to snow is 0.2, and I want that 3 times. But the probability it's not going to snow is 0.8, because remember, if it's 20% chance that it will snow, it's an 80% chance that it won't. But if I want it to snow 3 days, it means I want it to not snow 2 days. So I'm going to go to my graphing calculator. We're going to crank this out. So let's see what I said. I said 5, you have to press math, go over to probability, and it's number 3. 5 choose 3 times 0.2 cubed, press over so that doesn't get done again, 0.8 squared. And when I do that, it says there's a 0.0512 probability, or we can say approximately 5% chance. Now, there is a way to do this on the graphing calculator without having to use that formula, although I really do like that formula. And it's binomial PDF. PDF stands for probability density function. And you're going to use your N, your P, and your R. So if I do this again, binomial PDF, I wanted the 5 days with a 0.2 chance that it's going to snow, and I want 3 days. You may be wondering why you don't have to put it in the queue, but once again, it's a calculator, so it recognizes that if you have a 0.2 chance of it snowing, there's a 0.8 chance that it's not going to snow. So my number of trials is 5, the p-value is 0.2, and I want it to happen 3 times. And sure enough, I get the same value. Oops, sorry. I get the same value, 0.0512. Alright, so I'm glad that worked out. So now, we're going to do something else. Let's see if I can. And once again, if you have problems with this, you can always watch this again. Now, I want to find out what's the probability that it's going to snow at most 3 days. Well, that means it could be the probability of 0 days, plus the probability of 1 day, plus the probability of 2 days, plus the probability of 3 days. Well, I'd have to do binomial PDF of 0, then 1, and then 2, and then 3. But you don't actually have to. The key word is here is this, because you can do binomial CDF. The C stands for cumulative. And if we do that of an NCR, it will do exactly the same thing that I did right here. 0, 1, 2, and 3. That's great. And let's take a look. So to be binomial, runaway calculator. binomial CDF of 5 days, 0.2, and I want it to be at most 3. And that gives me, wow, 0.99328. 0.99328. And what I should do is I should do probability of 0, probability of 1, probability of 2, probability of 3, probability of 4, probability of 5. I'm not going to actually do that, but if you did that and you added up 0, 1, 2, and 3, you would get 0.99329. Now, if it says the probability of at least, let's say at least 2 days, you run into a little bit of a problem. And I'm going to explain how we can rectify this. 100% would be the probability of 0 plus 1 plus 2 plus 3. I'm going to run out of room, so I'm just going to put down 4 plus 5, right? We know that's probability and probability, but I am running out of room. I want at least 2, which means I need to get rid of probability of 0 and the probability of 1. When we do a cumulative density function, it starts at 0 and it goes until you tell it to stop. So, for example, we did 0 and we told it to stop at 3. But I want it to do and for this example, I want to do 2, 3, 4, and 5. So what I'm going to do is, I'm going to subtract 0 and 1, because remember, the probability of 0 and 1 is the binomial CDF of 5.2 and 1. So that's this. So if I subtract that from 1, remember 100% is 1 whole, so 1 minus this will leave me with this here, which is the probability of 2 plus probability of 3 plus probability of 4 plus probability of 5. So let's check it out. Let's see what happens here. So I'm going to say 1 minus binomial CDF of n. Now I have 5 days. The probability that's going to snow is 0.2. And my r, it says at least 2. But really, I don't want to get rid of the 2. I want to just get rid of the 0 and the 1. So I'm going to use 1. So let's see. I'm going to go to my graphic calculator and see what happens. I'm going to do 1 minus the binomial CDF of 5.2 and 1. And when I do that, I get 0.26272. Let's see, 26272. Good. All right. So really, I'm going to sum this all up very soon. If you want to find a binomial probability of exactly r trials, or sorry, n trials r times, you have binomial PDF. You guys can say if you like, and it's n NPR. If you want at most, and here's the key, at most, it'd be binomial CDF of NPR. And if you want at least, it's 1 minus, that stands for the 100, the binomial CDF of NP, and that's going to be R minus 1. Because remember, this was at least, this was at least 2, so 2 minus 1 is 1. And you can also do a between. But my video is too long right now. Between is actually kind of neat. If it was going to be between 2 and 5 trials, best thing to do is, let's see, 0, 1, 2, 3, 4, 5. I would do a CDF for 5. And then I'd do a CD, and then I would subtract it for a CDF. CDF for 5, and minus a CDF of 1. And obviously it'd be 0.5, or 5 and 0.2, and then 5 minus that, and that would be a between. All right, I hope this helps. Enjoy.